Welcome to my second lecture on list. So in this lecture, we're going to look at the Python function, and also we're going to solve some problems using list. So the first thing I need to do is to make you guys understand function. Like I said, this data science class is not for people that already know Python. It's not only for people that already know how to use Python. It's for both people that doesn't know how to use Python and also people that know how to use Python to get your hands strong using Python, right? So the first thing we need to do in the last video, we showed how we defined a list and we manipulate a list. So here we're going to create a function, and then we're going to solve some basic problems, right, using the function. So now, what is a function? A function is a block of reusable code that enables you to perform a specific task, right? I told you guys the reason for knowing these two main data structure in Python, which is a list and dictionary, because it's necessary when learning data science, right? It's very, very necessary. But it's very important to understand this data structure. Okay, so now to define a function in Python, what we do is to use def, then the name of the function. So let's call the name, let's do a simple example. Like I want to do an addition to add two numbers, right? So I have a variable called a, right? I have a variable called a, then a is like showing 200, right? So I have a variable called b, 500. So you can see that Python is implicitly typed, right? So I don't need to declare the data type, right, for the interpreter to understand that a is an integer, right? So now the end I'm returning a plus b, right? So what this function does is it collects it collects 200, a collects 200 and b collects 500. So I'm returning the 200 plus 500 will give me 700. So to run that, we use the same print, and I'll call my function, which is addition. Then I run this. So to run this is the py, right? Then the script is list.py. So it's 700, right? So what if in some instances where I want to dynamically key in any numbers, right? So I don't need to statically define it within this function here. So what I will do is to remove this and then put an argument here, or a parameter, which is ab, right? So this ab becomes an argument, right, in this function. So that means when I'm printing the function, I have to pass the argument here. So let's assume that a, which is not necessarily that you can put because you have a variable name called a and you put a in it. No. So let's use x for instance. So let's say x is 500, right? And let's say c is 300. Now you can, it depends on which one you want to represent a. Now I can decide to say, okay, my x should represent a and my c should represent b. So I'll have my x and c, where x comma c. So it means that x is representing this function a, this argument a, and c is representing this argument b. So it's not necessarily that if you have a name, you must put that same name. No, right? So I've seen so many errors like that when I'm lecturing some students that think they know what they are doing, right? So this is just it's a very simple thing, but most students make this mistake. Okay, so now if I run this, okay, if I run this py list.py, okay, can concatenate int. Okay, sorry, there's a command in this x. So if I run this py list.py, so it gives me 800. It gives me 800. So even if I change this to 800, so this will give me 1100. Let me just copy this. Sorry, my drop down is not working. That's why I can't replace this. So it gives me 1100. So that is how function works, right? It's a block of physical code, right? So you can see what it does. So now let's go for our topic for today. So the topic for today's list, right? So we'll try to solve one problem. We'll try to solve some problems, right? So our first problem is to find a number in an array, right? So now let's use the function called find number. s is find number in array. So most times I like define my function like this. So when somebody say find number in array, so the functions actually tell you to find a number in particular array, right? So my first argument can be an array. It can be, let's call it a. You can call it a, right? You can call it any name, right? So most times it's good to actually call it a name that actually reflects what the variable does. So I have array here. Now I can have a variable called target, right? So now the first thing I need to do, right, is to get the length of my array, which I can have a variable called n to get the length of my array, which is the function is len, and then pass array, right, and pass this argument here, right, I've passed it here. Now let me show an example. Let's assume we have p. Let me use p. So I have an array here: 45, 77, 34, 12, 33, 23, 67, 77, 87, 103, 72, 71. Okay, now let's assume that I have these arrays that contains an element, a number, integers, right? All integers. So now the first thing to do is to get the length of the array, right? To get length of the array, just counts the number of elements here in the array, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the 12 numbers, so it passes 12 here, right? Because, right, remember this is dynamic, so I can decide to change this, right? So even if you change this, because what at the end I'm passing this p to represent this array, so that's why I'm just using this to show the example. So I can, even if I change it, so what this does is it counts any number that is here, it calculates them, and then get the total length, right? So now the next thing to do is to use a for loop to loop through the array, right? So for I in range. Now, if I do it like this, a range of n, right? So it's from I, which I start at 0 by default, right? I start at 0 by default, down to the last, right? I start at 0 by default. But even if I want to manually key it in, I will just say from 0 down to n, 0. So it means that I is starting at 0. You can see I manually key it in to n. Even if you do it like this by default, it will take I as 0. But if you do it like this, it will still take I as 0. So if you do changes to 1, so it will skip this index 0 and start from 1, right? So now from I, let me just use simple like this for I in range of this, right? So what I will do here is if the array now, which is this array here, so if array of I, so what this means is, remember in the last video, if you run this array, right, you are trying to get the value in a particular index. So by default, in the first iteration, I is 0, right? I is 0. So if you pass I here, array of the array is this one here. Let's assume that the array is this. So if you pass I is 0, right? So index of 0, will give us 45. So if 45 is equal to the target, right? If it's equal to the target, we return. So depending on what we're returning, if I decide to return something like this, it means I'm returning the elements, right, in the index. But if I return I'm returning the index itself, right? So this is just a simple function. So we write a target we're trying to find, a variable called target. Remember we have two arguments here. So our target, let's say our target, I'm trying to find 87, right? I'm trying to find 87 in this array. So look at this now. Let me explain how this works. So at first instance, right? At first instance, I becomes 0, right? At first instance, I becomes 0. At second instance, I become 1, and so on until it gets to the last. So until it finds the element here. So if I change, let me print this and let's see how it works. So I will now change this. So my P is representing this array and my target is representing this target here. Or let me just use this S. So my S is representing this target here. So I will have P and then I will have S. Okay. So if I run this, I list dot I, right? So it's returning 8. So is 87 found in index 8. So let's find out. We have index 0 at first, 1, 2, 3, 4, 5, 6, 7, 8. You can see it's correct. So to make it look better, I can just decide to add some string message here that the target value was found in index, right? So we don't know the index, so because we're writing the function, you put the braces here, you close that braces, you put a string here. Now you can see those are all strings, right? So you need to add a format so that I can be able to see this function here. And to add a format, you put F here, right? So it's you can see this has changed. So I run my stuff again. So the target value was found in index 8, so you can see it's correct, right? So you can see how simple it is, right? So at first instance is 0, it compares with 87, so if it's not equal, it moves down to 1, if it's not equal, it moves down to 2, it's not equal, it moves down to 3, it moves down to 4, 5, 6, 7, and 8, and then found what it's actually looking for. That's why it's returning index 8, right? So, but if you wanted to return the value itself, all you just need to do is to change this and then run this. So if I run this again, it will just return the 87 for me, right? You can see 87. So, but what we're trying to do, we're trying to get the index where 87 is being located. That's why it's like this. So our second problem, you can see this problem works on, it runs on the time complexity of big O n, which is linear time complexity. So we won't look at time complexity or space complexity in this video because this is a data science class, not a data structure class, right? So if you want to know more about time and space complexity, so look out my videos on data structure where you get to know how this time complexity and space complexity works, right? So which is linear. Because most of the problem we're looking at here is linear. We're going to look at one quadratic time complexity problem, right? So this is linear time complexity. Okay. So let's do another problem. So let's assume that I want to get the maximum number in an array and also the minimum number in an array. Okay, they're all the same code, you just need to like change some few things. Okay, now I can decide to have, okay, let me leave this one. Let me write another function here. Okay, def to find the mass number, right? Find number in array. So I have one argument here, which is an array, right? So definitely I will have to get my length of the array. Okay, so I'll look through for I, right, in range of, now it depends on how you want to do it, right? It depends on how you want to compare it. I can decide to have a variable here called the mass, let's say the mass index, right, that we store the first index, right? Then my loop will start from 1, which will skip the first one because I've already stored the first index in this mass mean. So it's skipping the first one, right, down to n. So it's starting, so my I is 1, right? So my I is 1. So now if array of I, right, if array of I is greater than the mass index, right? If array of I is greater than the mass index, so what happens? I want the mass index, to collect the value in the array of I, right? I want the mass index to collect value in the array of I. So after this is done, I'm gonna return the mass index, which becomes the largest number. So now let's work it out. So the mass index takes the value in the first index here, which is array of 0, which the 0 is 45, right? 45 is in index 0. Now for I in range of 1, which means I'm not starting from 0. I is not starting from 0. I is starting here, which is index 1, right? That's what I have from I to down to the n, right? Down to the last. So now if array of I, which I is 77, is greater than this, so is 77 greater than 45? Yes, it's greater than 45, so store 77 here. So on the second one, when coming here, I becomes what? I becomes 2. So on this loop here, I becomes 2, right? I becomes 2. So 2 is 34. Is 2 greater than 77? No. Remember, your mass index is now 77. 2 is not greater than 77, no, so it does nothing, so it comes back again, right? It comes back again, I becomes 3, so 3 is 12, it does nothing. It comes back again, it's 4, 4 is 33, it does nothing. It comes back again, 5 is 23, it does nothing. 67 does nothing because it's less than 70. We have another 77, yeah, it's not greater than, so it's still there, so skip down. So we have 87, right? 87 is greater than, so 87 will now store in this mass index. So we now have a new number in the mass index, which is 87. So it goes again, right? So we now have 103 is greater than 7. So we now have a new number in the mass index with 103. And it goes again and goes again. And found that the 103 is actually the largest number. So when we run this, I can write, okay, let's write the largest number is. So I will call this function, right? So the function has just one argument, which is p, which is array, and p here is our array. So I will remove this s here. So I will run this pi, is a pi. So you can see that it has returned 103 for me as the largest number. So even if we have 1000 here, it will return 1000 for me as the largest number. 1000 for me as the largest number. So that is how it works. So if you want to get the minimum, it's the same thing. All you just need to do is to change the sign to less than, and it gives you the minimum. So let's just do that quickly. So let me copy this and let's paste this here. So find minimum, right? So all we just need to do is to change the sign. So that's all. So if I change this to find minimum, find mean, right? If I change this to find mean, is that the correct function name? Okay, show me an error. Okay, find mean. So if I run this, so it gives me 12. It's telling me that 12 is the smallest number. Yes, it's 12 is the smallest number. So that is how to do it. So now let's do one more example before we go. So the other example we're going to do here is to actually look at one of the complexity, which is big O n square, which is big O n square. Not n2, is actually n square. So since I'll just put something like this, big O n square, okay, which has to do with quadratic and complexity. So this is all about learning how to manipulate lists, right? So now let's just do one more. So what I'm trying to do here, let me just give a simple example, which is bubble sort. Now how bubble sort works is it compares the adjacency values within this adjacency elements here, like 45 and 77. Now if 45 and 77, if it, 45 is greater than 77, swap, else remains, then it moves on to the next one. If 77 greater than 34, then you swap it, the swap position. Now that is, it only works like this in ascending order, right? So it depends on how you want to do it. If it's descending order, it can be descending or ascending order. So if in ascending order, you can then compare it. If this is this, then swap this, swap and swap till you get the largest number down to the last index. That's what we're going to do. We're going to use the ascending order technique to do the bubble sort, right? So we have, it has a nested loop. That is why we call it the quadratic. That is why it's based on quadratic time complexity. So let's use and define the bubble sort. We call it bubble sort. Okay, now we have an array here. So the first thing is to pass the length of the array, which is the same. Okay, so now the next one is to loop through the array. Right? So down to n, right? Down to n. Now we now have another one. The first outer loop we determine the number of iterations, right, the inner loop needs to go through, right? So now the inner loop we now have for j, which is starting at, this will start at 0, right? I will start at 0 for j in the range, right, in the range of n, minus I minus 1. What we're doing like this is, so when we get them sorted down to the last index, on the next iteration, we will try to avoid the last one, and then it moves down to the next one. So I will explain that so that you see. So for j in the range of n minus I minus 1, right? So if array j, right, if array j is, if is descending order, you put less than, if descending order is greater than. So if array j is greater than the array j plus 1, if array j is greater than array j plus 1, so what I would do here is to swap them. So to swap array j, we now have array j plus 1 equal to array j plus 1, then array j. Now let me explain this. Remember the first iteration from I which down to 0, which is 7. So it's telling the inner loop to do 7 iterations with inside here, right? So now let's go through this. So our I is 0 down to n. So our j is n minus I minus 1. So the first instance of j, is n is how many? Let's count this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, right? So 13 minus I at first instance, I is 0. 13 minus 0 minus 1, right, will give us 12, right? So we now have 0 in the indexes. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So at the first instance is comparing all of them down to the last, right? At first instance. So now if array j, which array j is 0, right, I'll just start at 0, right, by default. So even if you don't want to put it by default, you can put 0 here, right? It still work like this. So it means array j in the range of 0 down to n minus I minus 1, right? So we have done it at first iteration, right? So it starts at 0. Now if 0 is greater than j plus 1 is 77, right? So if 45 is greater than 77, what it does is it swap. But if it's not greater than, it comes again, right? It won't come to I, because within this inner loop, right? So it will loop the number of times in the based on the outer loop, right? Based on the outer loop. So it comes again here, and it comes within j, not in I now, not in I. So it comes again here, right? It still maintains this n minus I minus 1, and then check which j becomes 1, which j will be 77, and j plus 1 will be 34. So if 77 is greater than this, it will swap, right? So 77 will come here, and 34 goes here, right? So it comes again within this inner loop, right? So j, right, it comes again within this inner loop, right? So j becomes 2, and that is how it keeps on going and keeps on going and keeps on going until the largest number is sorted down to the last index. So when that is done, that is when it will now move down to the outer loop, right? Then the outer loop becomes 1, right, which will now be n minus 1 minus 1, which means that we are no longer looking at this last index anymore, right? So n minus 1, if I is now 1, so it's now be 13 minus 1, which is 12, then minus 1, which is 11. So it now be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what the interpreter will do, we assume that the last one has already been sorted, because the largest index has gone down to the last, uh, the largest element has gone down to the last index, right? So that's what it does here. So that's how this code works, right? So the inner loops will loop through number of times the outer loop wants it to run. So once it's being done, that is when it comes back to the outer loop, and then the outer loop will now change to 1. That is how it keeps on doing it until we get it sorted, right? So that is why it operates on the quadratic time complexity, because of the multi loops, right? More than one loop, right? More than one loop. So if there are more than three loops, let's say we have like three and q. So we have it's called quadratic time complexity. Okay, there are so many time complexities, right? So if you want to know more, look at my videos on time complexity so you can understand that very well. Okay, so we are done with this. So we need to return our sorted array. So I'll go outside my for loop. At the end of this, I'm returning the array, right? I'm returning the array. So I went outside the loops, but at the end of all these, I'm returning my array. So if this array is this, right? So if I call this function here, you can see this array is not sorted. So if I pass this, okay, you can see how it is now sorted, right? So I have in ascending order, and I have 12, 23, 33, 34, 45, 67, 71, 72, 77, 77, 87. You can see how correct it is, right? I would have teach you guys more how you can manipulate lists, right? So you can see how simple it is using lists. So our next video we'll look at dictionary. Then after dictionary we'll look at numpy, then from numpy we'll look at pandas, then we'll look at how we can be able to explore and clean our data, and that's when you now start understanding data science class. I hope you guys understand this. Thank you and God bless you.